Page 150, explore multiplication and division with decimals. Okay. Now, what we're going to start with today is just something pretty basic, and we may just kind of work through this lesson and then jump right into the next. This is kind of like an introductory lesson to decimals. We just wrapped up a bunch of lessons on fractions. The natural progression now is to kind of move into decimals, which fractions and decimals are pretty much the same thing. Fractions and decimals usually have, well, they can have the same meaning. It's usually a portion of one, or one whole. Any fraction can be written as a decimal, just like any decimal can be written as a fraction. And there are certain rules that go along with multiplying and dividing decimals, just like there were certain rules that went along with multiplying and dividing fractions. Okay, so it's a matter of us just kind of getting familiar with the basics of each. Okay, let's kind of cover multiplying decimals first. Okay, when we multiply decimals, basically we account for the decimal last. It's the last thing we do. The last thing we do is worry about the decimal in our product, meaning our answer when we multiply. Okay? We account for the decimal last. Decimals themselves do not change or alter any of the multiplication facts that you've learned ever since you started learning your multiplication facts. What decimals will do is we'll ask you to do something after you've already covered those facts. Yep. Account. Okay. No Casimir today, huh?
Nope.
Okay, now if we were to look at a very basic, very simple multiplication problem like 2 times 3, okay, there are decimals in this problem. Okay? So to some extent, if you hadn't realized that you were working with multiplication problems that did have decimals in the past. What's different is we don't have anything after that is of any meaning. I could put something there, I could put zeros there, but you know that zeros don't really mean anything if there's no real integer after it. So what is 2 times 3? We would say 2 times 3 is 6. Now, 0.2 times 3. Now, remember what we said in red, we account for the decimal last. So for now, we are just going to completely ignore that it's there, and we're going to focus on just what is 2 times 3. Now, once I've gotten the product, then I ask myself, how many decimal places do I have in that particular problem? We have 1 because we have 1 digit after a decimal place. So if that's the case, you know, my decimal would usually be here, just like it was up there. I'm just going to move it 1 place. So it's 0.6. Okay? Because there's 1 decimal place. The fact itself stayed the same. If we go ahead and say, okay, 0.2 times 0.3, we'll take care of the decimal last. What is 2 times 3? 6. But instead of just 1 decimal place, I have 1 and 1, which make 2. So I have to move this decimal 1, 2 places. What's going to go in between the decimal and the 6? A 0. So it's really 0.06. The facts had stayed the same. 2 times 3 is still 6. What changes is the number of decimal places that are there, okay, which you might see, okay. So if we had 0.5 times 0.9. Now the integers that we can focus on are going to be what? What are we actually going to be multiplying first, Mariah? And what is 5 times 4? 45. But I know I can't leave it as the 45 because I know that that isn't a whole number 5 and that's not a whole number 9. How many decimals are here? 1. And 1 make... I need to go 2 places. So 1, 2 equals 0.45 or 0.45. Okay, the multiplication stays the same. What happens is we move the decimal based on how many decimal places are there. Okay, so I'm going to give you a couple to try. Okay, with the multiplication. 0.7 times 0.7 and 0.6 times 4. Okay, so 7 times 7, Maya, 49 with how many decimals? 2, so 1, 2 puts it right there, 0.49, or if you had 0.49, that's great. How many of you got that? Awesome. Next one, 6 times 4 is 24. How many decimal places, how many places after the decimal do we have in this one, Leah? 1. So I'm only going to move 1. I should have 2.4. So you have to pay attention. You're not robots. Okay, you're not conditioned. I think I tricked you. Some of you were just doing 2, 2, 2. You got to see what's there. Okay. And so if we were to say 0.04 times 0.06, what are the digits that we can actually multiply? 4 and 6. So Dekayla, that would be what? 24. But this one has how many combined decimal places? Liam, 4. So I'll need to move. That's where my decimal starts. 1, 2, 3, 4. How many spaces, extra spaces are there for zeros there, Dekayla? 2. So 0.0024 would be what we're looking for there. Okay. So the math, the multiplication, should be somewhat mental math. You should be able to do most of these facts in your head. It's just a matter of moving the decimal. Edsel. What do you mean? Because there's 1 there, or 2 there, 2 there. Okay? Does that answer your question? Okay. Okay. All right. With division, (1 2) divided by 4 tenths. Carlos. Well, if we were actually doing this, the 0.4 would go there, and the 1.2 would go there. Okay, so if we kind of just rewind here for a minute and say, when we divide with decimals, we will account for the decimal when? If multiplication has an opposite as division, right? Multiplication is the opposite of division. And if in multiplication you take care of the decimal last, well, what's the opposite of last? First. So we'll count for that first. So when we divide with decimals, we want to really make sure we've got our decimal taken care of first. So now, if we take a look ahead, we were able to do a lot of the multiplication facts, most of that stuff in our head. When you get to the division, it gets a little bit more confusing to try to figure out what it is you're actually working with. So the best course of action I'm going to recommend for today is that you at least just set it up this way. If we account for the decimal first, we must make sure that what's on the outside is a whole number. Is 0.4 a whole number? How am I going to make it a whole number? I can just move the decimal. If I move it one place, that 0.4 now became just a 4. So what gets done on the outside must also get done. So if I moved it one place to the right on the outside, I'm going to move it one place to the right on the inside, and I'm going to bring it right up top. Then I say, how many times does 4 go into 12? And that 3 goes over the 2 and the 12, and there is your final answer. Now we can get into the fact that, okay, they both have one decimal place, they're going to cancel each other out. I can just think, how many times does 4 go into 12? And it's going to be 3, and I'm going to be just fine. But I think as we work through the beginning stages of this, it's better to visualize it this way. Okay, I think in the long run it'll help you understand it a little bit better than just trying to reason it out other ways, because we could easily confuse. So how about this next one? 0.56, 0.8. Okay, so we always put what we divide by on the outside, and we always put what's being divided on the inside. Okay, so if we are going to take care of the decimal first, I want to make sure that what's on the outside, what I'm dividing by, is a whole number. How am I going to make a 0.8 a whole number, Alexis? One place. So if I went one place on the outside, how many places am I going on the inside? One. That's going to put it in between the 5 and the 6. It's okay. You say, wait a second. You can't put 8 into 5. Sure you can. Part of 8 goes into 5. Part of it. Not the whole thing, but part of it. So 8 doesn't go into 5, but 8 goes into 56 7 times. Okay? So 0.7 would be our answer. It doesn't go in a full time. Okay. Yes, Carlos. What do you mean? there is no whole number because 8 doesn't go into 5 one whole time, right? 5 is smaller than the 8, so it's not going to go in one whole time. That's why. I can fit some of 8 into 5, right? Some of it, just not the entire thing. Which is what you don't necessarily get when you work with remainders. We talked about working with remainders and big boy math and all that kind of stuff, right? Okay. So I've got a sheet that I want to kind of go through together, okay, as we kind of get used to what's going on here. This one has a lot more sample problems on it for us. Desi does? Okay, number 1, 0.2 times 0.3, going back to multiplication. So our facts, 2 times 3, 6, with how many decimals do we have? How many decimal places do we have? 2, so I'm going to go over 2. 1, 2 becomes 0.06. Let's skip over to number 3. We'll come back to the division when we got it all at the same time. Number 3, 0.1 times 0.9. Okay, so our facts say 1 times 9, 9, with a decimal place there, a decimal place there. 2 becomes 0.09. Right now, do the rest of the multiplication problems on this page. Just the multiplication. Skip over the division for now. So number 8, we set them up as such. 1 place on the outside, 1 on the inside. Should be 0.7. Right? 1 place on the outside, 1 on the inside. Should make this one 0.6. 1 place on the outside, 1 on the inside, 0.8. 1 on the outside, 1 on the inside, 0.1 on the outside, 1 on the inside, 0.6. And 1 on the outside, 1 on the inside makes it 0.8. And then the last one is a 0.4 and a 0.28. 1 on the outside, 1 on the inside, 0.7. Okay? Any major issues on those? Some of you got all of them?
Yes.
Good. If you write them out, it's a lot easier to see, okay? The facts themselves, just like with multiplication, the facts themselves don't change all that much. It's just what you do with the decimal, okay? And decimals are what makes numbers what they are. So where the decimal is. It's the difference between $1 and $1 million. Where the decimal is. Okay? Say it. Okay? So that's all I have planned for you today. I was not planning on giving you any homework. I wanted to go through that together. Now, before you thank me, just be aware that if it looks like in the next, 20 minutes or so that you have nothing to do, then we'll start on tomorrow's lesson. Okay?